All right, so we've talked about equations with one variable, so solving for x, solving for a, b, y, that kind of stuff. Now we're going to be talking about functions, which is an equation with two variables. Okay, sometimes even three. So, a function is just a mathematical representation that shows the relationship between two variables. It's just our mathematical way of showing the relationship between x and y, or x and y and z. Okay, we're going to be talking about two variables. Now to actually write the function in mathematical terms, we use f of x, or sometimes g of x, h of x, it doesn't matter. This is the function name. This is your input. This is what you're putting into the equation. And that equals what you get out of it. So f of x, you're going to see a lot of. And that is read, you say f is a function of x. So as an example, we would have f of x equals x plus 1. Okay? This function is a function of x, and you'll see that x is in our equation. Another way to write this, okay, another way to write f of x is just y. Okay? F of x and y are interchangeable. So if you see f of x, just think y. So y is a function of x. Okay, you plug in something for x and you get y. Okay, so x is going to be your input. Look over here. X is your input, and that will equal your output. So this whole thing is your output. Okay. Since we're dealing with x and y, we're going to be talking about coordinates on a coordinate plane. Hopefully you know a little bit about these. But a coordinate is just, it gives you an exact position or an exact solution. So in our coordinate plane, we're going to have x on the horizontal line and y on the vertical line. So a coordinate will look something like 1, 2. Okay? This gives you your x, and so x is 1, y is 2. Okay? So coordinate just tells you an exact solution. So if x is 1, y is going to give you 2. If x is 1,000,000, y might give you 2,000,000. Okay, it just tells you an exact location. Now when we're talking about functions, this will actually produce sometimes a line, a curve, stuff like that. So there's a certain boundary that your function has. Now our domain is going to be all possible x values. Okay, it's basically your horizontal boundary. You might have something that goes like this. Okay? Your boundaries, okay, there's your horizontal boundary, whatever this distance is. This goes from -5 to 5, okay? Your domain is going to be in there. Okay, so the domain is all possible x values. You'll notice this is a line, so every point in here is a solution. If we're talking about range, that's going to be all possible y values. Okay, it's basically your vertical boundary, because y is our vertical axis. So for our range for this one, it would just be whatever these points are. Between these points is our range. Okay? So domain is just x values, range is y values. And make sure all possible x, all possible y values. Make sure you can tell the difference. Okay, so let's look at a couple examples. These are just a bunch of coordinates. Okay, just a bunch of coordinates. So let's just plot these. We have 1, 1, 3. We have 1, 2, 3, 4. -4, -2. 3, 3. And then 2, 9's way up there. Okay. There is no connection between these. Okay, there's no line connecting all of these. Okay, it's just the points themselves. So we can't have any x values in between here, in between here. Okay, it's only these specific points. So if we're talking about domain, it can only be these specific x's. Remember, domain is x. So how we list the domain for these types of problems is you start with your curly bracket, and you list all the x values from smallest to largest. So we have -4, 1, 2, 3. And there you go. Okay? That is your domain. There can be no other x values because there's nothing connecting here. Okay? Now make sure if you have any questions that you circle them or star them or something so that when we come back, I can help you figure something out. Okay? I can answer any questions you have. So we got our domain. Range is our y value, so we look at our y's. We have 3, -2, 3, 9. So our range, we're going to do the same thing. Curly bracket. We list from smallest to largest. So our smallest, -2. We have 2 3's. We don't list both 3's in our domain or our range. We only care about one of them. So we do 1, 3, and then 9. End of our curly bracket. Okay, if you had a whole bunch of the same thing, your range would be very small. And there's nothing connecting here, so these are the only values you can have for your x and y's. Now if we're talking about a function, is it a function? It has to pass the vertical line test. Okay? All that means is basically we do our little vertical line. So we bring a ruler like this, and if there are 2 points on the same vertical line, that's not going to be a function. Okay? If there's a point up here and here, that would mean they have the same x values. So vertical line test, same x equals no function. Okay? So we look, are they the same x's? We have different. They're all different. So this one is a function. Okay? You have to look at the x's. They're the same, it's not a function. If they're different, then it is a function. Okay, same x, not a function. Different x's. Yes, it's a function. Remember, f of x is how we mathematically write functions. I'm just shorthanding it, so I have to spell it. Same x's, not a function. Different x's, yes, it's a function. So let's look over here. Remember, these are just points. There's nothing connecting here, so these are our only possible values. We look at our x's for our domain. Remember, domain is x. So we do our curly bracket. We go from smallest to largest. So we have -3, 0, and we have 2 1's. We're not going to list both of them. That'd just be redundant. You only list one of the 1's. And that'd be our domain. For range, we're talking about the y's. So we look at our y values. Okay, do a curly bracket. We have 2, -5, 1, and 6. So we'll go from smallest, which is -5, into 1, 2, and 6. Okay, since these are points, these are the only possible values you can have. If we had a line or a curve or something like that, then this would look a little different. But since these are points, it's just these values. It can't be anything else. Okay? Is it a function? Let's look. X, we have 1, ooh. We have 2 of the same x's. Which means if we drew this, we'd have 0, 2, 1, -5, -3, 1, 1, 6. Something like that. If we took our vertical line, oop, these two are both, okay? If y is 2 different things at this point, we can't have that. So this is not a function. And it did not pass the vertical line test. We have 2 points at the same x. Okay, we got one more. Look at our domain. That's the x's again. 2, 4. This time we have 5 points. So, since these are the only values we can have for x, we're going to list them from smallest to largest. So we got -2, -1, 0, 2, 4. Curly bracket. Okay? Our function can only exist at these 4, 5 x's, nothing else. So we look at our range, that's our y value. We got a couple here. Do our curly bracket. We have -4. Oh, we got another -4. We don't list it again. That'd be redundant. So we have -4, then we have -3, 0, and 2. Okay, so our x's, these are the only possible x's we can have. That's our domain. For the range, these are the only possible y values we can have. There's our range. Is it a function? Okay, we look, x's, they are all different. If they're different x's, that means it is a function. Okay, make sure you write this down. If you have any questions, circle it, star it, something, so when I come back, we can go over it and address anything that we need to. Okay, here's just an example of a possible problem. So you'll see domain and range. Remember, domain is your x's, range, those are your y's. So let's write this information as points. Remember, points are x, y. So we're going to take our domain, comma, range. So 1 point, let's just look at, over here we have 0, 0. Let's look at another point. We have 1 going to 1. Okay, these arrows mean that this x value is associated with this y value. So if you have multiple arrows, maybe going like this, that means you have 2 x coordinates. So you have 1, 1, and 1, 4. Okay, so we got 0, 0, 1, 1. Another point is 2, 4. Okay, 2, 4. Another point, we got 3, 9. Just 3, 9 right there. And lastly, we have 4 and 16. X's are always the first coordinate right here. Always. Then goes your Y. Okay, so we've got our points. Now we have to figure out the domain. Remember, domain is X. That's our X's. So we go from smallest to largest. We have 0. So we do a little curly bracket, 0, 1, 2, 3, 4. Those are the only possible values for X that we can have. Okay, we can't have anything else. So if we look over here, our range, that's our Y values. Range is Y. So we look at our Y's. We have 0, okay, 0, curly bracket 0, 1, 4, 9, 16, curly bracket. Okay, hopefully you guys are able to do this pretty quickly. You just have to know domain is X, range is Y. Don't list any duplicates, just one is good. Now we're going to do function notation. This is a little different. Remember, function notation is f of something equals something. So for this one, remember x is in our parenthesis here, in our little guy right here. So we're going to go to the specific x's. So f of 0 is going to be equal to 0. Remember, another way to write f of x is y. So here's our x's, y, xy, 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 xy. Okay? F of x is really just y. So when x is 0, when x equals 0, y equals 0. Okay? When x equals 0, y equals 0. That's all it's saying. Okay? When f is 0, the function 0, or y equals 0. So let's take a look at another one. So when f is 1, so the function at 1, when x is 1, what does y equal? Okay, you look at your coordinates, y equals 1. Okay, this is just when x equals 1, y equals 1. When x equals 2, y equals 4. And we're just looking at our ordered pairs, our coordinates. When f equals 3, what does y equal? And we know, when x is 3, y is going to be 9. And finally, when x is 4, y is going to give you 16. Okay? So function notation, you're just substituting in the x's and the y's. So you plug your x's in here, and you just list your y's. So when x is 0, y is 0. When x is 1, y is 1. Let's see it. When x is 1, y is 1. When x is 2, y is 4. 0, 0. When x is 3, y is going to give you 9. And that's all function notation is, that's all it's asking you to do. Plug in your x's and your y's. Okay. Part D, explain what happens if the 4 went to 9. So if we had 4, 4, so 4, 16 goes to 4, 9. Okay, what happens? All that would mean is that your little arrow would go like that. This would mean we have 2 of the same y values. Can we have the same y values? Okay, yes we can. Remember, passes the vertical line test. We just can't have the same x values. Okay, so you would just have the same y values in two different coordinates. What would happen if the 2 was paired with 4 and 1? So let's take a look at this. If the 2 was paired with 4 and 1, okay, that would mean we would have 2, 1 and 2, 4. Okay? If you notice, these both have the same x's. If they have the same x's, is it a function? The answer is it fails the vertical line test. Not a function. Okay, you get 2 of the same x's. Can't do it. Make sure you guys write this down. If you have any questions, write them down so that we can go over them when I come back. Okay? I want you guys to try this one. In your groups, you need help, do just what we did. So you're going to write them as points, so convert, remember, domain is x. Range is y. Write them as points. Then write the domain and range as sets with the curly brackets. Then write it in function notation. Then do a little explanation. So in your groups, work on this example. All right, so let's go over this. Write them as points. So our first point, where x is x and y. Our points, we have A, I. So A is our x, capital I, or 1, talking Roman numerals, is our next point. Next one, A goes to 3. It'll be A and 3. Then we've got B, 2. And we've got C3. And finally, D goes to 4. Okay, this one's a little tricky because it's letters and Roman numerals, not so cool. But it's important to know that if you have two arrows coming from one x, that means you're going to have two of the same x's, or multiple of the same x's. And is that a function? No, does not pass the vertical line test. So, let's write our domain. Remember, these are just points, there's nothing in between, so it has to be a set like this. So we do curly bracket. We don't know which one's smallest to largest, so we'll just go in order. Okay? We got A. We have multiple A's, so we don't write them. A, B, C, D. Okay? For the range, we're going to be looking at the y values. So we go from smallest to largest. We have 1, 2. We have 2 3s. We don't care about both of them. We just want one of them. So our range, curly bracket, we got 1, 2, 3, 4. Curly bracket. Okay, we don't care about the duplicates. We only want one of each. For function notation, remember that's f of something equals something. So f inside here we put our domains, our inputs. So when f is a, when x is a, you get 1. When f is also a, okay, it's a different a, it's the same a really, but when x is a, you get 3. So this a right there, that one's right there, f of a gives you 3. Okay. When x is b, you get 2. Okay. F is b, you get 2. When x is c, you get 3. Finally, when x is d, you get 4. Remember, this is just your input, this is your x's. This is whatever your y is. So for our ordered pairs, it's always x, y. So f of x, our x goes here, and our y's go here. Okay, for part D, explain why or why not this is why isn't this a function? We know that functions have to have the same or different x's, Functions have to have different x's. This one has 2 of the same x. So it's not a function. No function. Same x's. Okay, vertical line test. If these were points, you could plot them and do the vertical line test. But you know, if there's the same x's, it's not a function. Okay, let's look, see if they're functions. Remember, input. That's our x. Output is our y. Remember, f of x, these are all x's. These are all y's. So let's look real quick in your groups. Is it a function? Is it a function? Is it a function? Okay, so let's look at these. If it's a function, we have to have different x's. Different, 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 different. Yes, this has different x's. Let's look over here. We have a 3, that's different, different, different. Oh boy. We have same x's, which means it is no. Same x. Now this one might be hard to tell, but you can do the vertical line test. Okay? This one is not the same as this, so those are good. Go, 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 go. There's this guy. Oh. Same x's. So that means it is not a function. Same x. Okay, vertical line test. Look at the x's. If there's any duplicates for the x's, you know it's not a function. Okay, we got a word problem. Okay, so we have to fill in the table, graph the function, label the axes, state the domain and range, and tell if it's a function or not. Okay? So, we know that the cost of sending a text message costs 10 cents per message. Now we've done a lot of practice of taking a word problem and making an equation or an inequality or an expression, something like that. So our equation, our cost, which is a function of the number of text messages we send, is going to be equal to 0.10 times each message. So our cost is a function of the messages. So if I were you, I'd write cost equals function of number of messages. Okay, the cost is a function of the messages. Okay, you kind of think of this as y equals 0.1x. Kind of think of it like that. Okay, so independent variable. Independent variables are the things that we change. So we're going to change the number of messages. So if we have one message, how much is it going to cost? Okay, you plug it in, you get 0.1 times 1, which gives you, gives you 0.1. Let's say we have two messages. This is going to be 0.1 times 2, which gives you 0.2. 3 messages, 4 messages. You guys fill these out. See this pattern? It's going to be 0.1 times 3, which is 0.3. Okay. Our independent variable here, this is the m's. So we plug this m in right there. Okay. 1 message, 2 messages, 3 messages, 4 messages, 0.4, 0.5. We sent 1,000,000, you'd get, okay, just follow the pattern. let's write this in function notation. Remember, that means that our cost, actually let's do real generic. Alright, so it's f of m equals some number. So for us, it's going to be the cost of one message is going to be 0.1. The cost of two messages will be 0.2. Okay. Cost of 3 messages is equal to 0.3. Cost of 4 messages equals 0.4. Cost of 5 equals 0.6. Oh, my bad. 0.6. Cost of 5 messages is 0.5. Okay, so all we got to do, you look, we have, that goes right here. That's your number of messages. And then this is right there. So the function when x, or m in this case, when m equals 4, the cost is 0.4, 40 cents. Okay, let's put this in coordinate notation. Our independent variable, that's what we're changing, that's our input, that's our x. Our dependent is our y. So to put this in a coordinate, we have one message, 0.1 cents, or $0.1. Two messages, 0.2. 3 messages, 0.3. 4, 0.4. Finally, 5, 0.5. Okay, make sure if you have any questions about this, you write them down. When I come back, we can address them. So, we have our table, we have our x and y values. Now we need to graph the function. So our axes are already labeled for us. Generally you do the y and the x, okay? Or dependent variable and independent variable. So our cost is going to go up here, and our messages are going to go down here. So we have one, and we need to figure out what our axes, our grid lines are going to go by. So for our messages, let's look. Ours are going up by 1. So it makes sense to go 1, 2, 3, 4, 5. For our cost, you'll notice that's only going 0.1, 0.2, 0.3, 0.4. So it makes sense to label this 0.1, 0.2, 0.3, 0.4, 0.5. Now you have to keep track of your points to make sure that your axes make sense. And all you do is you graph. So you have 1.1, 2.2, 3.3, 4.4. Okay. Now since this is a function, it's not just these points that are possible. This could go on for 6, 7, 8, 9, 10, blah, blah, blah. Can you send half messages, like 1.5 messages? Okay, you can't send half a text message. It doesn't count if you send it but it's not delivered. That still counts. So there's nothing, you can't have anything in between here. Okay, there's no line here, it's just the points. So let's check out the domain. Okay, our domain for this, that's our x's. We're going from 1, 2, 3, 4, 5. So our domain should look like 1, 2, 3, 4, dot, dot, dot. It goes on forever. For our range, we're going from 0.1, 0.2, 0.3, 0.4, 0.5. 0.1, 0.2, 0.3, 0.4, dot, dot, dot. It goes on forever until you run out of money, your parents run out of money, they're tired of paying your bills. Okay? Then lastly, is this a function? Okay, if it's a function, we have to look at the x value. So are the x's all the same? Are any of them the same? No, no duplicates. So yes, this is a function because they are different x's. Or different m's, technically. I know this is a lot, but just know this is your x's. Plug it into the equation, into your function, you'll get your y's. And this is just different ways to write it. Okay, so let's look at the previous. Here's the equation. C of m equals 0.10 m. Okay? The cost, which is a function of the messages, is equal to 10 cents times each message. Okay? How to put this problem into words? You have the cost of 15 messages. Cost of 15 is equal to 0.1 times 15, which is really 1.5. So it costs you $1.50 to send 15 text messages. Let's say we had 29 text messages. Okay. Your cost, which is for 29 messages, that's going to be equal to 0.1 times 29, which is 2.9. So it costs you almost $3 to send 29 text messages, which I know you guys can do in like 30 seconds. Okay? You guys are way too popular. Let's think about this. Is it possible to have a bill of $3.45? Okay? Can you have $3.45? If you can't see this right away, what you can do is you can set your cost, you know it's $3.45 equals 0.1 m, and solve for m. To do that, you would divide by 0.1. You get m is equal to 34.5. Can you send half messages? No, so this is not possible. We've already talked about this a little bit. Is it possible to connect the dots? Remember, this is number of messages. Can you have half a message right there? No. So you cannot connect the dots. Okay? You can't have half messages. Let's explain D. F of 51 equals 5.10. This 51 is the number of texts. This is the cost. So F of 51 equals 5.1 means that when you text 51 texts, it costs you $5.10. That's all it means. Okay, now it's your guys' homework. It's going to be looking at graphs, make sure, okay, you can do the vertical line test. You can actually get all these coordinates if you can't do the vertical line test. You're going to have these guys. Okay, keep track of all these arrows. So this is going to be one going one one going there. So keep track of those arrows. Okay? Now you've got a big long set of points. Remember, the domain and range can only be from this set. Can't be any others. And we got a couple of word problems. Okay? Table again. So you want to label this, label that. Okay? So when you're going, make sure that, let's just give this one to you. $5 gift card from each download. Each song costs $1 to download. The amount of money left on the card can be represented by that, where D is the number of songs. So down here is going to be number of songs, and right here is going to be, you can say money left. Something like that. Okay, you always want to label your graphs. So in the notes real quick, I know we went right here. To label this, we'd want to say, we could say cost and number of text. Something like that. It doesn't matter. As long as it's pertaining to whatever you're graphing. Okay, but you always want to label your graphs with a title and proper intervals. Okay, so if you had any trouble on any of this stuff, make sure you circle it so when I come back we can go over it.